Imagine you turn on the news, and there a calm-voiced announcer reports. The government officially warns of a catastrophe that could claim the lives of 300,000 people and cause damage of $1.8 trillion. Sounds like a disaster movie script, but unfortunately, this is the reality of modern Japan. For the first time in history, the Japanese government has issued an official warning about a mega earthquake, an event so destructive that its consequences will surpass all natural disasters since World War II. We are not talking about some distant theoretical threats. We are talking about a scientifically substantiated forecast based on analysis of tectonic activity that has been accumulating for decades. The epicenter of this apocalypse will be the Nankai Trough, a 900-kilometer underwater depression off the southern coast of Japan. The most terrifying thing about this situation is the predictability of the catastrophe. Earthquakes in the Nankai Trough occur with frightening regularity every 150 years. The last major event occurred in 1946. Simple arithmetic tells us that the time has come. Japanese seismologists have raised the probability of a mega earthquake to 80% in the coming years. But many experts believe that we won't have to wait that long. For example, Doctor of Physical and Mathematical Sciences Alexei Lubushin, analyzing seismic noise data, states, "The planet's cardiogram in the Japan region has begun to resemble the indicators of a person with tachycardia. Instruments are recording chaotic bursts of high amplitude, a sure sign that something terrible is being prepared in the Earth's depths. Recent years' events only confirm these grim forecasts. Since January 1, 2024, more than 850 earthquakes of various magnitudes have been registered in Japan. The strongest of them, with a magnitude of 7.6, became the most powerful in Ishikawa Prefecture in the last 140 years. But what really frightens scientists is not the earthquakes themselves, but their character. Modern events demonstrate an unusually large number of aftershocks, which may indicate a preparing main strike. Japanese authorities treat these warnings with utmost seriousness. A special state of readiness has been introduced in the country. When the mega earthquake finally strikes Japan, seismic sensors scattered throughout the country will feel it first, but people will have only a few seconds. In some areas, a maximum of 2 minutes to understand that the very event everyone was so afraid of has begun. Seismic waves begin their deadly march at a speed of 8 kilometers. First come primary longitudinal waves that compress and stretch rock. A few seconds later, they are caught up by transverse waves that make the Earth sway from side to side. But the most destructive are surface waves that roll across the Earth's surface like tsunamis on land, with amplitudes of up to several meters. In 10 of Japan's 47 prefectures, residents will feel underground shocks of 7 points intensity, the maximum mark on the Japanese intensity scale. To understand what this means, you need to know that at 7 Japanese points, people cannot stand on their feet. They are literally thrown into the air. Furniture flies around rooms as if weightless. Even reinforced concrete buildings begin to sway with amplitudes of several meters. But the earthquake is only the beginning of the nightmare. The real horror will begin in 10-15 minutes when a tsunami approaches Japan's shores. Billions of tons of ocean water suddenly come into motion, forming waves that move at the speed of a jet plane. In the open ocean, these waves are practically invisible. Their height is only a few dozen centimeters. But when the tsunami reaches shallow water off Japanese shores, something terrible happens. Wave speed slows down, but their height rapidly increases. Water that moved at a depth of 4 kilometers is forced to pass through space only 10-20 m deep. The laws of physics are inexorable. Energy doesn't disappear anywhere, it transforms. The 2011 tsunami, whose height in some places reached 40 m, showed what angry marine elements are capable of. Then waves penetrated inland for distances up to 10 kilometers, turning flowering valleys into lifeless wastelands covered with silt and debris. Cars floated down streets like toys in a bathtub. Multi-story buildings were uprooted and carried hundreds of meters. But in the case of a mega earthquake in the Nankai Trough, the scale of destruction will be even more terrible. Why? It's about geography. The epicenter of the future earthquake is located much closer to the densely populated areas of southern Japan than the epicenter of the 2011 events. tsunami waves will require less time to travel to shore. They will be higher and more powerful. A particularly terrible fate awaits Tokyo. Japan's capital is built in the lowland delta of several rivers, and a significant part of the city is located below sea level and protected only by dams. When 10-meter waves crash into Tokyo Bay, they will break through protective structures. Seawater will rush into underground metro tunnels, turning the entire transport system into a death trap. Fires will become a particularly terrible disaster. The earthquake will damage gas pipelines, power lines, oil storage facilities. Thousands of fire sources will ignite simultaneously, while fire services will be paralyzed due to destroyed roads and lack of water. Modern computer models show a truly terrible picture. In the first week after the catastrophe, 2.5 million buildings will be completely or partially destroyed. That's every fifth building in the country. Every 10th resident of Japan will be left homeless. Japan's history is written in the ashes of tectonic catastrophes. The island nation is located in the very heart of the Pacific Ring of Fire, a geological zone where 4 giant tectonic plates converge: Eurasian, Pacific, Philippine, and North American. This hellish kitchen of nature makes Japan the most seismically active country on the planet. About 1,500 earthquakes occur here annually, although most of them are so weak that they can only be felt with special instruments. But once in centuries, tectonic forces accumulate enough energy for a real apocalypse, and these catastrophes repeat with frightening regularity. On September 1, 1923, Japan was shaken by an event that forever changed ideas about what an angry planet is capable of. The Great Kanto earthquake, with a magnitude of 8.3, turned Tokyo and Yokohama into blazing ruins in a matter of minutes, but the most terrible thing began after the underground shocks. In those times, Japanese houses were built mainly of wood, paper, and straw materials that ignited like gunpowder. The earthquake occurred at noon when millions of families were preparing lunch over open fires. Overturned braziers instantly turned entire neighborhoods into a fiery hell. Wind fanned the flames, creating fire tornadoes hundreds of meters high. Temperatures in the epicenter of the fire tornado reached 1,000 degrees Celsius, enough to melt copper. The total number of victims of the Great Kanto earthquake reached 105,000 people. But this was not just a natural disaster, it changed the very DNA of the Japanese nation. It was after 1923 that Japan began total preparation for the next inevitable strike of the elements. But perhaps the most terrible lesson was taught by the earthquake of March 11, 2011. Shocks with a magnitude of 9.1 off the eastern coast of Honshu Island became the most powerful in Japan's history. Tsunami waves up to 40 m high swept entire cities off the face of the earth. But the main nightmare was the accident at the Fukushima Daiichi nuclear power plant. The designers of the nuclear power plant provided protection against tsunamis up to 6 meters high. This seemed more than enough, but nature turned out to be much more terrible than human calculations. A 14-meter wave easily overcame protective dams and flooded the station. Seawater disabled diesel generators that powered emergency cooling systems for reactors. Without cooling, nuclear fuel began to overheat and melt. Hydrogen explosions occurred at 3 power units, destroying protective shells. Radioactive substances were released into the atmosphere over an area of 1,000 kilometers squared. 160,000 people had to be evacuated within a 20-kilometer radius of the station. Many of them still cannot return home. Fukushima became the largest nuclear disaster after Chernobyl. Even earlier in 1707, the Hoei earthquake occurred, one of the most destructive in Japanese history. Underground shocks were so powerful that they awakened the sleeping volcano Mount Fuji. The sacred mountain erupted for 16 days, covering half of Japan with ash. So scientists have discovered that all these catastrophes are connected with the same geological process. The Philippine Sea Plate continuously presses against the Eurasian Plate at a speed of 4 centimeters per year. This seems ridiculously slow, but over a century, an offset of 4 m accumulates. When tension reaches a critical point, sudden energy release occurs. The plates jerkily return to their original position like a giant spring compressed to the limit. This process is inevitable. Starting from 2020, seismic activity in the Japan region demonstrates anomalous surges. The curve that previously oscillated chaotically suddenly sharply went upward. This is a classic sign that dangerous changes are occurring in the depths. Modern events completely fit into the historical pattern. The 2024 earthquake in Ishikawa Prefecture demonstrates an unusually large number of aftershocks, more than 850 shocks in several months. Such activity in the past always preceded major catastrophes. Now we can look at how Japan prepares for dangerous events. After the 1923 catastrophe, the country turned into a giant laboratory for developing anti-seismic technologies. When Japan began building high-rise buildings in the 1960s, engineers faced a paradox: how to create a structure that would withstand an earthquake of 9 magnitude. The answer turned out to be unexpected. You need not to resist, but to move in rhythm with underground shocks. Modern Japanese skyscrapers are built on the principle: it sways but doesn't collapse. The steel frame of a building is designed to bend under the action of seismic waves like bamboo in the wind. Massive pendulums weighing hundreds of tons are installed on roofs. During an earthquake, these pendulums swing in anti-phase, with building oscillations dampening destructive vibrations. The most impressive example is the Landmark Tower skyscraper in Yokohama, 296 meters high. A pendulum weighing 510 tons is installed on its top. During a strong earthquake, the building can deviate several meters from vertical, but thanks to the pendulum, it returns to its original position. But the real breakthrough is flying houses. Air Danshin Company has developed a system that lifts a building on an air cushion at the moment of an earthquake. When detectors register the first waves of an earthquake, powerful compressors pump air under the foundation in a fraction of a second, lifting the house 2-3 centimeters. Thus, the building literally hangs above the ground while destructive seismic waves pass beneath it. No less amazing are tsunami protection systems. After the 2011 catastrophe, Japan spent $12 billion on building new protective structures. Concrete walls up to 15 meters high grew along the eastern coast. In some areas, evacuation towers were built, reinforced concrete structures 15-20 meters high capable of accommodating thousands of people. These towers are designed to withstand a direct hit from a 40-meter tsunami wave. On the roof of each tower are supplies of food, water, and medicine for several days. But Japan's main protection is a culture of preparedness. Every Japanese person has known earthquake behavior rules since childhood. Schools conduct monthly drills, workplaces hold quarterly training. Special attention is paid to psychological preparation. Japanese mentality is a separate topic. During the 2011 earthquake, there was no panic or looting in evacuation centers. People patiently waited for help, shared food and water, cared for the wounded. Even the Japanese mafia yakuza during natural disasters turns into a rescue service. Clans allocate people and money to help victims and organize delivery of humanitarian aid to cut-off areas. Even more futuristic looking are underwater observatories. On the bottom of the Pacific Ocean, right above the epicenter of the future mega-earthquake, a network of seismometers connected to the mainland by fiber optic cables is installed. These instruments register every tremor of the seabed in real time. But the most ambitious attempt to look into the future is the Nankai Fault Deep Drilling Project. The Japanese drilling vessel Chikyu drilled a well 3 kilometers deep directly into the tectonic plate, just 1 mile from the epicenter of the future catastrophe. Scientists, for the first time in history, were able to touch with their hands the zone where a mega earthquake is being prepared. The drilling results turned out to be shocking. This discovery fundamentally changed understanding of processes occurring in the depths. Perhaps the fault is ready to break at the slightest push. And recent discoveries have complicated the picture even more. Scientists have discovered the phenomenon of slow earthquakes, seismic events that develop over weeks, not seconds. In 2015, 2020 deformation waves were recorded in the Nankai Fault that rolled over a 30-kilometer section of seabed over several weeks. These slow earthquakes can release part of accumulated tension, reducing the risk of a catastrophic event, but they can also be a trigger for rapid release of all fault energy. It's like Russian roulette, only on a bigger scale. The global consequences of a Japanese mega-earthquake extend far beyond Japan itself. The modern world economy is so interconnected that stopping Japanese production will immediately resonate throughout the planet. Japan is the world's third economy, a center of high-tech production. Here, 90% of the world's electronic components are produced, 60% of industrial robots, 40% of semiconductors. The Asia-Pacific region will suffer, especially Singapore, Hong Kong, South Korea. All these economic centers are closely integrated with Japanese industry. Breaking supply chains will cause a domino effect. Factories in China will stop, ports in Thailand will close, stock markets from Sydney to New York will crash. But there is an even more terrible prospect, a new Fukushima only many times bigger. Currently, 33 nuclear power plants operate in Japan, many of which are located in the damage zone of the future mega-earthquake. After the 2011 accident, all nuclear power plants were modernized, higher protective dams were built, emergency cooling systems were strengthened. But will this be enough against a 30-meter tsunami? If waves break through the protection of at least one station, radioactive contamination will cover huge territories. A tsunami in the Pacific Ocean will reach the shores of all countries in the region. Waves 2-3 m high will crash on California, Oregon, British Columbia. The Philippines, Indonesia, New Zealand will also be in the damage zone. For many Pacific islands, even 2-meter waves will be a catastrophe. But ultimately, the outcome of this battle will depend not on technology, but on human spirit. The Japanese have lived for centuries under the sword of tectonic catastrophes, and this threat has created a special national character. When the mega-earthquake finally strikes, and this is a question not of if, but when humanity will, for the first time in history, meet a planetary catastrophe in the digital age. We have technologies, protection systems, evacuation plans, international aid mechanisms. But is this enough against a force that can move an entire country? We will know the answer very soon. The Earth under Japan is trembling ever stronger. Seismic sensors are recording anomalous signals, and scientists are increasingly using the word inevitability.